So good morning to all. In this video we will discuss how the 8-bit multiplication programs are done in assembly language program for 8085 microprocessor. So in 8085 microprocessor we have addition and subtraction. We don't have any instruction for multiplication and division. So therefore multiplication has to be performed by repeated addition. For example, when we are multiplying 5 into 4, so either 4 has to be added for 5 times or 5 has to be added for 4 times. So that is the concept behind the repeated addition programming. So we will try to implement the same with the help of 8085 assembly language instructions. Okay. So now let us understand where the inputs are stored. So two numbers are there. One number is a multiplicand that is stored in 4200 memory location. Second number is a multiplier that is stored in 4201 memory location. So the result may be having a 16-bit number based on the input given. Because when we are multiplying two 8-bit number, so maximum of 16-bit number is possible. If for clarification, what do we do is we take a calculator. So in hexadecimal, the maximum number is FF multiplied by FF. So the result is FE01. So this is the maximum result in 8-bit multiplication. So there is a possibility of this number when the inputs are high. So when the input are very low, then you can get the result in 8-bit itself. For example, if you multiply that let us say 45 multiplied by 5, so the result is 159. So 159 is also a 16-bit number. You can see it is more than 8-bit. Actually it is a 12-bit number. So let us say if it is 10 multiplied by 8, so it's a 80. So it's a nothing but an 8-bit number. So we should understand that there is a possibility of 16-bit number in the result. Therefore we keep two numbers, we maintain two 8-bit data for the result. Okay, one is LSB and another one is a MSB. Okay, so MSB can be generated whenever carry gets generated. The carry is keep on added whenever it is generated, then it becomes MSB. So during the addition, whatever we are getting in the accumulator, that can be the LSB of the result. Okay, that we will discuss and see that how it is done. So this is a memory pointer. Initialization of memory pointer HL register pair is 4200, which means that now M register is having a value of the content of 4200, which means M is equal to 5. That is the meaning of M register. M register is always having a value which is pointed out by the HL register pair. Now HL register pair is having the value of 4200. 4200 is having a value of 5. So that 5 is stored in the M register automatically. Now then we are initializing accumulator into 0. But then same 0 is copied to C register, which is used for carry. And now we are moving the first number to the B register. So the B register is having the first number initially, and then what do we do is we are incrementing the memory pointer to 4201. Now the M becomes 4. M register is having a 4 register. So now what do we do is initially B is having a B register is having a 5, because memory is having 5. It is copied to B register, that is here 5 is there. Now we are comparing the B register content, that is 5 is compared with the accumulator. Already accumulator is having 0. So when it is compared, when the B is also equal to 0, that is a multiplicand is also equal to 0, then what will happen? We have to go to the loop 3, which means loop 3 we are simply results will be 0, because when the 0 is multiplied with any number it becomes 0. So we just see accumulator is having a 0, that is copied to memory. After incrementing the memory pointer is incremented, which means 4202 will be the memory pointer now. So there we are moving 0, and then we are moving the memory pointer, and 4203 it becomes then 0. C is already having 0, that is copied to memory pointer. So one thing is we are comparing the input multiplier or multiplicand to 0. When the input is equal to 0, then the output should be 0. That is what we are doing here. Now if it is not 0, of course now it is not equal to 0. Now it is 5 is one register and 4 is in another register. So what we are going to do is add m. M means accumulator is equal to what happened? This m plus what is the content of accumulator now? Content of accumulator is 0, isn't it? So we will say content of accumulator is 0. So I will type it here so that content is accumulator is 0. Now we just say it is equal to m plus accumulator content is equal to 0. Now we have got a 4. So now what do we do is we are adding jump no carry. Now the carry is generated? No, it is only 4. So decrement the B register now. So B register is 5, then it becomes 4 now. Okay. So I would say decrement means this minus 1. Okay. Yes, fine. So decrement the B register, whether it is become 0? No. Then go to loop 2. Loop 2, what is there? Add m. What is in m? M is in 4. So we are just adding m with the accumulator. Accumulator is nothing but 4. So the 4 is maintained here. We will maintain 4. So this formula I am just simply copying. So we just 8. So 8 is the content of, so what it is? 4 plus 4. Okay. A simple formula I have written in Excel. Let us see whether it's working. Again now, what is the next step? We are just comparing no carry. Now carry is not generated. Increment the, no, you cannot increment the C because the carry is not generated. So you go to loop 1, decrement the B. So B is decremented, okay, 3. Now is it 0? No. Repeat the process. Again add the m, then it becomes 12. So 12 is actually BC, isn't it? In hexadecimal it is C. So it is a decimal value. It is a hexadecimal value. Okay, fine. Now also there is no carry. Please remember. Now what do we do is we are just no carry, jump to decrement B register. So it becomes 2. After decrementing, is it 0? No, we repeat it again, add it again. So we just add, it becomes 16, decimal number. Okay, once again we are decrementing. This is 1. After decrementing, is it 0? No, we are adding one more time, so it becomes 20. So now when we are decrementing, it is a 0. It's a 0. Therefore what happened? When it becomes 0, jump no 0 only, it is going there. If it is 0, it will go to increment INX So memory pointer is now 4201. You can see memory pointer is initialized at 4200. It is incremented once, so it is 4201. Now again we are incrementing, it becomes 4202. 4202, and then moving the content of the accumulator to the memory register. So content of accumulator is copied now 20, that is copied to memory register, that is 4202. We become 20. Okay, see LSB, I told no LSB becomes 20. Now move the content of C register. What is the content of C register? It is 0 only. I mean, it is content of C is 0. So that is copied to next memory location, that is 0. So the result is 20 in decimal, and actually in decimal if it is 20, in hexadecimal it is only 14. So 5 into 4, it's 14 is the hexadecimal value. Now let us discuss the same program with another example so that we get carry also. So let us multiply A3 for 4 times, and we will do it in calculator itself. See, we have got A3 multiplied by 4 times, which means that we have to add 4 times. Now what we will get is A3 plus A3. So now we are getting 146. 146 means 1 is taken as a carry and 46 is available in the accumulator. Okay, so this is the result. Now next time we are not going to add this A3 with 146, but actually A3 will be added with 46 alone. Okay, so 46 is added with A3. So now we are getting no carry. So which means that carry is maintained as 1. This is 1 and then E9. This is what is the result now. This is the third time we have added. So fourth time when we are adding now plus A3. So what we are getting is 18C. So 8C will be in the accumulator, and this 1 is there, no? This 1 is added with the this C register. Already C register is having 1. Now it is a 2, isn't it? So now we have added 2, 3, 4. Now 4 times we have added. Let us see whether we are getting the same result. That is A3 multiplied by 4 times. We are getting 28C. See, 28C is the answer. So now we can understand how the carry is being keep on incremented whenever it is generated. We are performing only 8-bit addition here repeatedly. I hope you understood the concept of 8-bit multiplication from this video. Thanks for watching, and whatever doubts you have, you can ask me in the comment box. I will answer all the questions, and connect with me for more such videos. Thank you.